So, what time, yes? Okay. So, what I'm going to talk about today is the next section, total internal reflection. So what this is exactly is, well, an easy example is, you're on a tram or a bus or just, looking out a window. You can see what's through the window. I can see there are trees there, but I can also see a reflection of the plant next to it. Right? I can see a reflection, but I can also see through the window, which would be an example of refraction. Right? Total internal reflection deals with the combination of the two. So you'll notice this with our glass box here. The light coming in hits the glass, it refracts, so it changes direction, then hits the glass and changes direction again. But you also notice there is a bit of a reflection here as well. So usually, when you have a beam of light going from one medium to another, there is refraction as well as reflection at the same time. You usually have both. And what that depends on is it depends on the angle of incidence, right? So the angle of incidence is where the light beam is coming in. So depending on how big that angle is, determines how much light is refracted and how much light is reflected. Okay? So you can have, both things at once, but depending on where you are, can have one or the other. So here, I know this is kind of hard to see, but I have 4 different examples here. Well, actually, I'll fill in some of this. So this is my incidence ray. This is my other one. There's a little bit here. Here's this one. There. And then here's this one. Okay. So this one coming in is my incidence ray. This one coming out is my refracted ray. Right? In, coming out, in, coming out, going in. And then these ones here are a little bit of a reflection. So, for the picture A, the angle of incidence is small. So remember, the angle of incidence is measured from the normal. So it's measured if I were to draw a straight line right here. So this is our angle of incidence right there. Okay? So the angle of incidence is small, so most of the light leaves the block. Most of the light is refracted. Okay? So this one, as the angle of incidence gets bigger, more light is reflected in the block and less leaves the block. So there's more of a reflection here, and the refracted ray is getting, the angle of refraction is getting bigger and bigger. So as the angle of incidence is getting bigger, the angle of refraction is also getting bigger. Okay? Now, there is a point for this one here where eventually at a certain angle, the refracted light is at 90 degrees, or it goes parallel to the outside of our block here. So that angle depends on where the light is going into. If it's going into glass, a diamond, water, something like that, the angle changes. But at a particular angle, the refracted light is parallel with the outside of our block. Okay? And then once your incidence ray is bigger than whatever this angle is, so the incidence angle is bigger than that particular angle, which we call the critical angle, then all of the light is reflected and no light comes out. So all of the light goes in and out this way. So no light is refracted after that certain point. With me so far? Okay. So this particular angle here we call the critical angle, which I will get into more detail on the next few slides. So recap, small angle, most light is refracted. As it gets bigger, the angle of refraction is getting bigger. At the critical angle, the refracted light is parallel to the top of the block there, and then it's bigger than the critical angle, all of the light is reflected. So when the angle of incidence is greater than the critical angle, the light is entirely reflected inside the glass, so this is known as total internal reflection.
There's this course, and when you were doing the one,
It's just like the one. I don't know why this is here. That's weird. Well, for whatever reason, that got in the way, so we'll just put that up there. Okay. So when all of the light is reflected, that's total internal reflection. And the critical angle depends on the material. So I have three here, glass, water, and diamond. So glass, the critical angle is about 42 degrees. Water, it is about 49 degrees. And a diamond, about 25 degrees. Okay, so any incidence angle greater than these in those materials, all of the light is reflected inside. No light is refracted. Okay? So, the total internal reflection can also be related to our refractive index that we talked about last time. So last time we talked about the refractive index N, and we can relate that to our total internal reflection, so our critical angle. So the greater the refractive index of a material, the smaller the critical angle. So you can use Snell's law to see how the critical angle C and the refractive index N are related. So if we remember this from last time, refractive index is equal to sine of I over sine of R. So that's what we talked about last class. So when the angle of incidence equals the critical angle, the refracted ray bends at 90 degrees. So that's where, I'll go back a couple here. So that's this point here. So when the angle of incidence is equal to our critical angle, the refracted light is parallel to the top, so it's at 90 degrees. So I can rewrite this as sine of 90 over sine of our critical angle, whatever that one happens to be. Now sine of 90 degrees is equal to 1, so that becomes 1 over sine of C. So the relationship here is the refractive index is equal to 1 over the sine of the critical angle, or the sine of the critical angle is equal to 1 over the refractive index. Okay, so that's how we can relate those two. So here, I have my formula, sine C equals 1 over n. So the refractive index of diamond is n equals 2.40. So find the critical angle C. So to do that, well, we should all know how to do that, I hope. Maybe. So, all we have to do is solve for C. So sine of C is equal to 1 over, and n is 2.4. So, so C is equal to sine to negative 1 of 1 over 2.4. And that should give us about 25 degrees, which is what I said the critical angle of a diamond should be. So sine inverse of 1 divided by 2.4 critical angle of a diamond is 24.6 degrees, which is about what we said it would be. Okay. So very simple calculation with these ones, nothing too complicated. Do we have any questions about that example? You with me? Mark? You know, following? Okay. So I think I had one more. Sure. So one thing that makes use of total internal reflection are optical fibers. So I'm sure you've heard of these before. Generally, well, they're used a lot in telecommunications. So telephone companies have these optical fibers that they use instead of cables that they used to. So for example, telephone calls are sent as a flashing laser. And the light just bounces in this cable, you know, going up and down, and it never leaves the cable, because if this is our cable, for example, right? I guess I'll use red. So if this is our light beam, it just hits the top, bounces off, and it just keeps bouncing inside this cable. And so on, right? That's how optical fibers work. So the inside of these things is made of glass, is made of fine glass. So the light is constantly bouncing over it, or bouncing into it, because the angle of incidence is not small enough that light would leave the cable, that it would be refracted. So it uses this idea of total internal reflection and the critical angle to keep these lasers inside of this cable. So that way, telephone calls, you know, you can send the information much faster. It's traveling at the speed of light or so. Then the information is also very clear because you're not losing any information along the way. This also can be done or be used in medicine. So doctors have a little scope basically that they use that some of it sends light through so you can actually see what's going on because it's really dark inside of your body, I'm sure you'd guess. And then also with light going through the cable so you can see, it also reflects in such a way that you can actually look through it and see whatever it's pointing at. So you can see inside, you know, somebody's body to perform surgeries or, you know, inspections of sorts. You know, you'll get used to that when you're old and have to have physicals. So can be used in many different areas. Those are, of course, are just two basic ones. So are there any questions about total internal reflection? Excuse me. We all followed along? Mark, you good? David? Okay.